All right, so this is from the Chapter 3 packet. The problem is you probably don't have your Chapter 3 packet, so you can kind of listen through the notes, see if it helps you on the homework. You can always do it on paper or get your packet from me, so you can always send me a message and pick it up. All right, so we are doing notes for 300. This is Chapter 3. So simplifying algebraic expressions. So it says in an algebraic expression, like terms are terms that have the same variables raised to the same exponent. So they have to have the same variables. So like x or x squared and an x squared, or y to the third power and 4y to the third power. So they have to have the same variable and the same exponent. Constants are terms. Constant terms are also like terms. So if they don't have any letters with them, you can combine the numbers. To identify terms and like terms in an expression, first write the expression as a sum of its terms. So first thing we're going to do is identify the terms and then see if there's any like terms. Now for me, this is my personal, what I like. I circle the terms, but they include the sign in front of it. So that's like a positive 10. This one right here, since it has a minus there, I treat it as a negative 3 over 2y. So our terms would be y, 10, and negative 3 over 2y. Those are the terms. There are 3. Now, like terms, I see 2 of them that have a y. So the like terms would be y and negative 3 over 2y. So those are like terms. And you've covered this in 6th grade. So terms again. Here's a term. Here's a term. So see how I include the sign that's in front of it. So if I write those terms now, it would be 2r squared, 7r, negative r squared, and negative 9. So you don't have to put the positive, but the negative of, yes. Like terms. Okay, I see one right here with an r squared, and here's one with an r squared. So 2r squared and negative r squared. Not the 7r because it doesn't have the same exponent. All right, let's go ahead and turn the page. So try this one. This one has 5 terms. Remember, you can always pause the video if I'm going too fast for you. So we have 7, 4p, negative 5, p, and 2q. So, like terms, I see a 4p and a regular p. So 4p and a p. Now, the 2q, there's no other q, but do you notice the 7 and the minus 5? Both of those are constants. They do not have any variable with it. So you can actually, those are like terms. So 7 and negative 5. So those are the like terms. Okay, an algebraic expression is in simplest form when it has no like terms and no parentheses. To combine like terms that have variables, use the distributive property to add or subtract the coefficients. So the distributive property, remember that's where you have something on the outside. You go A times B and A times C. This one, A times B A times C. The minus is still there. So that's distributive property. So let's look at some. So this one, there's no parentheses. Good. Can we combine into like terms? Yes, this one has a y and this one has a y. So if I have a positive 15y and I have a negative 10y, since they have different signs, I'm going to subtract. That's going to give me 5y, and it's more positives. So the variable just stays there. It's the numbers that we're either adding or subtracting. All right, let's look at the next one. Now this one has a G, this one has a G, and this one has a G. So if I start right here, change that to plus a negative, this one plus a negative. If I have a 2.4 and a negative 2.4, I'm going to end up subtracting that. That's 0 G's. So if I have no G's, and I'm going to add that to a negative 9.8 G, my answer is just going to be a negative 9.8 G. Okay. All right. Let's look at the next one. Identify the terms and like terms in each expression. So that's what we've already done. So it kind of just shows you. There it is. So they say change it to addition plus negative plus negative. When I circled my term, do you see how that made it a negative 2 and a negative x? That's why I circled the term, so I don't really have to change it to addition. Then listed the terms and then the like terms. So that's just another example from the book. And here's another example from the book. So they change it to addition by adding the negative. So now it's a negative and then the like terms. All right, now here's one with distributive property. We didn't do one like this. Oh, no, they do it opposite. Never mind. So what they do on this one, 6n minus 10n, remember, I would go plus negative 10n. So I would go negative 10n and 6n. Subtract negative 4n. What they do is they factor out the n. So they use the distributive property, take the n out. You got 6 minus 10, which is negative 4n, which that's what we ended up getting to. And then this one right here, they all have w's, so we have to combine them all. Now the key thing on this one is if the w by itself, it's understood to be a 1 with it. So you combine them all, you end up with negative 2.3. All right, so go ahead and try homework number 300. I don't think there's any distributive property on that one. I think I save it for the next lesson. So good luck. Get that done. There's only 12 problems today, so you should be able to finish it.